Today I'm going to demonstrate a homogeneous and heterogeneous mixture. Matter is a physical substance. An element is a substance that cannot be decomposed into simpler substances. A homogeneous mixture is a mixture where the components that make up the mixture are uniformly distributed throughout the mixture. I'm going to be mixing Kool-Aid with water. And I will be stirring it with my spoon. And this is a homogeneous structure. A heterogeneous mixture is a mixture where the components of the mixture are not uniform or have localized regions with different properties. I will be mixing my milk with my cereal. This is a heterogeneous mixture.
Hello, today I'm going to be talking about chemical properties and chemical change. I'm going to be giving a demonstration of what a chemical property is and what a chemical change is. But first, what is a compound? What is a molecule? What is a substance, a pure substance? A compound is a thing that is composed of two or more separate elements. A molecule is a group of atoms bonded together representing the smallest fundamental unit of a chemical compound that can take part in a chemical reaction. A pure substance is a substance that is made of only one type of atom or molecule. My demonstration for chemical properties would be flammability. Flammability is the ability of something to catch on fire, like paper, for example. Paper catches on fire. So, hold up this paper, light it on fire, it catches on fire. Chemical change. Chemical change. My example for chemical change would be a rotting banana, as you would see in this picture here. The reason why I chose a rotting banana to be my example for chemical change is because there's a change in color, and the change is irreversible.
Alright, so I'm going to be doing a homogeneous mixture first, and for that I'm going to be using water and sugar for sugar water. So I've got my cup of water here and my sugar here. For this mixture, I'm just going to pour a little bit of sugar in here. Then I'm going to mix it together, kind of do that. And as I mix this, it's going to distribute evenly throughout the water, which actually makes this a homogeneous mixture. And you won't be able to see it just because it's sugar, which is tiny crystals and in a clear liquid. But this will make this a homogeneous mixture because the sugar is distributing evenly throughout the water. So the physical properties of the sugar are going to be kind of like a grainy substance, which everybody knows, it's sugar. Tiny crystals, white crystals of sandy, grainy substance. And then the water, of course, is just a clear liquid, white. And this would also be a physical change because if you were to evaporate the water, all that would be left behind is the sugar crystals, basically. So that would be a physical change because it is not changing the substance of the water, it is mixing in it. Alright. So I'm going to set that aside. Sugar water is going to be a homogeneous mixture and a physical change. And then the physical properties, like I said, water, wet, clear, sugar, sandy, and grainy. So yeah, that is my first experiment, and my second experiment is going to be for a heterogeneous mixture. And for that we're going to use a cup of soda, which is right here, and some ice, which I actually have in a bowl right now. For this, I'm just going to add a few. First, the physical properties of ice are basically very slick. The ice is a solid and it's got a slippery, wet texture to it because it's frozen water. Now, if I add a few of those cubes into the soda, they are going to float there for a while, and after a while, you'll notice that the ice will eventually start to melt a little bit into the soda, and it might fizz a bit too. Even with the ice melting, that melted water wouldn't necessarily change the substance of the soda.